How can companies predict stock prices, sales, or even weather patterns? The answer lies in time series forecasting. In this video, we'll break it down step by step. Time series is simply data collected over time, like daily stock prices, monthly sales, or hourly temperature. Forecasting these patterns helps businesses plan smarter and researchers understand trends. Before we can predict the future, we must first understand the past. Think of a time series as a story told by data over time. To truly grasp this story, we can't just look at the whole book at once. We need to break it down into its fundamental chapters. In time series analysis, these chapters are 4 core components. Understanding them is like getting a secret decoder ring for your data. Let's dive into the first and perhaps most important component, the trend. The trend is the long-term direction of your data. It's the underlying persistent movement over a significant period, ignoring the short-term ups and downs. Think of it as the main journey of your data. Is it generally going up, down, or staying flat? An upward trend or uptrend shows consistent growth. Imagine the chart of a successful startup's user base over 5 years, or the increasing global adoption of smartphones. Conversely, a downward trend or downtrend shows a long-term decline. This could be the sales of physical CDs over the last 2 decades, and sometimes there's no discernible trend at all. The data just hovers around an average level, which we call a horizontal or sideways trend. Identifying the trend is crucial for long-term strategy. It helps a business decide whether to invest in expansion or rethink its entire model. Next up is seasonality. This component represents patterns that repeat at fixed, predictable intervals of time. The key word here is fixed. These are the rhythms in your data tied directly to the calendar: daily, weekly, monthly, or yearly. A classic example is retail sales. You can almost guarantee a spike in sales for warm clothes every winter and a surge in ice cream sales every summer. Similarly, e-commerce websites in India see massive traffic spikes during Diwali. This isn't just about yearly patterns. A city's electricity usage might peak every afternoon as people turn on their air conditioners, a daily seasonality. Or a restaurant might be busiest every Friday and Saturday night, a weekly seasonality. Understanding seasonality is vital for short-term operational planning, like managing inventory, staffing, and marketing campaigns to match these predictable peaks and troughs. Now, let's talk about a component that's often confused with seasonality: cyclic patterns. Like seasonality, cycles are recurring ups and downs in the data. But here's the critical difference. They are not of a fixed or predictable duration. While seasonality is tied to the calendar, cycles are tied to broader, longer-term phenomena. The most famous example is the business cycle in economics. An economy goes through phases of expansion and growth, followed by periods of contraction or recession. These cycles can last anywhere from 2 to 10 years or even longer, but you can't mark your calendar for the next recession. Other examples include the real estate market, which often experiences multi-year boom and bust cycles. Because their duration is variable, cyclic patterns are much harder to predict than seasonal ones. However, identifying them is essential for long-range strategic planning and managing economic risk. Finally, we have the fourth component: noise. After we've accounted for the trend, the seasonality, and the cyclic patterns, what's left over is the noise. It's the random, irregular, and unpredictable component of the time series. Think of it as the static in a radio signal. You can't predict it, and you can't explain it with a simple model. Noise can be caused by anything from data collection errors to one-off, unrepeatable events like a sudden natural disaster, a major political announcement, or a product going viral due to an unexpected celebrity endorsement. While we can't forecast the noise itself, it's incredibly important to measure it. If your data has a very high level of noise, it means your forecasts will naturally have a higher degree of uncertainty. It tells you the inherent limit of how predictable your data can be. So there you have it. Trend, seasonality, cycles, and noise. These are the four fundamental building blocks. Almost every time series you encounter is a combination of these elements. The process of breaking a series down into these parts is called decomposition, and it's the first practical step we take in our forecasting journey. By isolating each component, we can understand our data better and build more powerful and accurate predictive models. There are several ways to forecast. Statistical models like AR, Massachusetts, and ARIMA. Machine learning models like random forest or gradient boosting. Deep learning models like LSTMs and transformers. Alright, let's dive into the practical side of things with a Python demonstration. We'll walk through a complete, albeit simplified, time series forecasting workflow. Python is the language of choice for data science, not just because it's easy to learn, but because of its incredible ecosystem of libraries that do the heavy lifting for us. We're about to see how we can go from raw data to a sophisticated forecast in just a few steps. Think of this as our journey from looking at the past to predicting the future. Our first step is always to load and inspect the data. For this, we use pandas, the undisputed king of data manipulation in Python. Think of a pandas data frame, its core data structure, as a superpowered spreadsheet right inside your code. We begin by importing the library, typically as PD. Then, with a single line of code, we can load our dataset, which could be anything from daily stock prices to hourly website traffic. Pandas is especially brilliant for time series because it understands dates and times, making it easy to organize and prepare our data for analysis. Before we can forecast, we must first understand. Data visualization is a non-negotiable step. Here we use matplotlib, Python's foundational plotting library. By writing just a few lines of code, we can generate a line plot of our sales data over time. This simple chart is incredibly revealing. It allows us to visually identify key components of our time series at a glance. We can see the overall trend, are sales generally increasing or decreasing? We can spot seasonality. Are there repeating patterns like sales peaking every weekend? And we can notice any strange outliers or anomalies. This visual inspection guides our entire modeling strategy. Now for our first modeling approach, ARIMA. This is a classic and powerful statistical method available in the Stats Models library. ARIMA stands for Autoregressive Integrated Moving Average, which sounds complex, but the idea is intuitive. The autoregressive part assumes that future values have a relationship with past values. The integrated part involves differencing the data to make it stationary, a key assumption for the model. And the moving average part uses past forecast errors to improve the current forecast. ARIMA is fantastic for capturing the underlying structure in a time series and provides a solid, statistically grounded prediction. Next, let's look at a more modern tool, Profit. Developed by the data science team at Meta, Profit was built for forecasting at scale. Its biggest advantage is its simplicity and batteries-included approach. While ARIMA requires careful statistical analysis to tune its parameters, Profit is designed to work well out of the box with default settings. It automatically detects yearly, weekly, and daily seasonality, and you can even provide it with a custom list of holidays. This makes it incredibly fast and effective for common business forecasting tasks, where you need a reliable forecast without diving deep into statistical theory. So, we've seen two powerful approaches. On one hand, ARIMA, a robust statistical method that gives us deep insight. On the other, Profit, a modern automated tool that delivers fast and reliable results. The choice between them often depends on your specific goal, your data, and how much time you have. Now, let's look at the simplified code that puts all these pieces together. Finance, predicting stock or crypto prices. Retail, demand and sales forecasting. Weather, temperature and rainfall predictions. Healthcare, forecasting disease spread. In India, forecasting is transforming. Agriculture, predicting crop yields. E-commerce, helping startups optimize inventory. And there we have it. We've journeyed together through the fascinating world of time series forecasting. It might seem like a lot to take in, but let's just take a moment to look back at how far we've come. We started with the absolute basics, understanding what makes a time series special, that inherent order, that beautiful, irreversible flow of time. We learned how to decompose our data to see the hidden stories within the numbers, the long-term trends showing growth or decline, the predictable seasonal rhythms that repeat like clockwork, and the unavoidable random noise that keeps things interesting. We tackled the crucial concept of stationarity, understanding why it's the stable foundation upon which so many powerful models are built. From the elegant simplicity of moving averages and exponential smoothing to the robust and versatile framework of ARIMA, we've started to build a powerful toolkit for looking into the future. But as we've emphasized throughout our journey, time series forecasting isn't just about predicting numbers on a chart. It's about something far more profound and impactful. It's about making better, smarter, and more strategic decisions. It's about shifting from a reactive mindset, where you are constantly trying to catch up with the world, to a proactive one, where you anticipate what's coming next. In a world that is drowning in historical data, time series forecasting is the lighthouse that guides us through the fog of uncertainty, allowing us to navigate the future with confidence. Think about the real-world impact. For a massive retail company, accurate forecasting is the difference between a warehouse full of unsold winter coats in the middle of summer and having the perfect amount of stock ready for a sudden, unseasonable cold snap. It's about knowing exactly how many cashiers and support staff you need to schedule for the big festive rush, ensuring smooth customer experiences and maximizing sales. In the high-stakes world of finance, it's not a crystal ball for getting rich quick, but a sophisticated and essential tool for managing risk, balancing investment portfolios, and understanding the volatile heart of the market. For our healthcare systems, it's a lifesaver. Imagine a public health official using forecasting to predict the peak of the annual flu season. This allows them to strategically allocate vaccines, hospital beds, and medical staff, saving lives and preventing the system from being overwhelmed. The applications are truly everywhere. It's the power grid operator, forecasting electricity demand on a scorching summer day to prevent blackouts and ensure millions have the power they need. It's the tech giant, predicting server loads for your favorite streaming service to ensure your movie night goes without a single buffer. It's the manufacturer, scheduling maintenance for critical factory machinery right before it's predicted to fail, preventing costly downtime. This is data science in action, creating tangible, measurable value. And that is precisely why mastering time series forecasting is one of the most powerful and rewarding skills you can develop in your data science career. It's a beautiful intersection of statistics, machine learning, and crucial domain expertise. It challenges you to not just blindly apply a model, but to truly understand the context behind the data. This skill is in incredibly high demand across every industry because it directly translates historical data into future business strategy, efficiency, and growth. It's how you, as a data professional, can prove the immense value of data. So, what's your next step on this path? Don't let this just be another video you watched. The real learning begins now. Take what you've learned and apply it. Find a data set that genuinely interests you. Maybe it's historical weather data for your city, the stock price of a company you admire, or even your own fitness tracker data. Start simple. Plot the data. Try to identify the trend and seasonality with your own eyes. Then, run a simple model and see what it tells you. The key is practice, experimentation, and above all, curiosity. The journey of a great data scientist is one of perpetual learning, and we at The Data Key want to be your partners on that journey. If you found this detailed guide helpful, imagine what else we have in store for you. We'll be diving deeper into advanced topics like Facebook's profit model, using LSTMs and neural networks for forecasting, and even anomaly detection. To make sure you don't miss out, please do subscribe to the channel and hit that notification bell. Your support is what allows us to create more in-depth free content just like this, and we would love to hear from you. What part of time series do you want to explore next? Leave a comment below. Thank you for joining us and keep on learning.